What's up, everybody? Welcome back from your April staycation. Time to get back to the grind here. So we're gonna have about 2 weeks of new content coming up before we start to review for our exam. Now I know, right, this is a crazy time, and I know that, right, this is a struggle for all of us. You might be helping out at home. Hopefully you're helping out at home, right? You got a lot of, just whatever, social, emotional stuff we're all dealing with, stressful times, crazy what's going on, right? And I get all that. And so I'm here, all your teachers are here, all your counselors, right? It's everybody, right? We're all here to help. So if you guys ever need anything, don't hesitate to reach out, whether it's, stats related or not. But, that being said, we have put in a lot of work this year to get ready for this exam. And so let's just do our best to keep plugging away, keep learning, keep studying, keep reviewing. Let's not give up. It's a difficult environment, but we can do this, and let's try to earn some college credit on those exams and, really capitalize on all the work we put in, for 70-ish% of the year before this all went down. So that being said, let's jump right in. So we're going to start to work with some new confidence intervals and hypothesis tests this week and next week. In the past, so far, we've worked with categorical data percentages. So we've worked with one sample, two samples with percentages. Now we want to start to work with quantitative data with some means. So here we go. So today we're looking in our book, which is chapter 23. We now want to start to talk about confidence intervals and hypothesis tests for means, or in other words, we're working with quantitative data. So today, I'm trying to keep these videos a little bit shorter than they were in the last unit. So today, you can see I've broken this down into 4 we'll see this week. Let's talk about the one sample t-interval. Just so you know, the one sample there is in parentheses just because when we start to look at our graphing calculator, it just says t-interval. It doesn't say one sample t-interval. So here's our context. This is a question from a past AP exam. So take a minute, maybe pause the video, right? Tedious, but best thing you could do is to write this down in your notes, have all those there. Who knows, maybe you got to take stats again in college and you'll have a notebook with everything you need. So we've got some environmental group. They're looking at the lead levels of certain crows. It's classified that, or it's determined that greater than 6 parts per million is considered unhealthy. And so we're going to take a random sample of 23 crows in the region. This is our sample data right here, back to our old from the stem plot. And you can think about how you might describe this distribution, shape, outliers, whatever unusual features, center and spread. But we'll save that for another day. So for today, there are 2 questions with this free response. This is the same context. Number 1 here, this is review. Should take a couple minutes, not even, don't overthink it. What proportion of crows have lead levels that are classified as unhealthy? And you're going to want to jump back. Actually, I'm not going to say anything. Just do that. You got that. Don't overthink it. We want to focus on number 2 here. So we've got the mean lead level of the 23 crows was 4.9. So this is an X bar right here. This is the sample mean. Standard deviation was 1.12. That's a sample standard deviation there, right, based on the 23 crows. And our job is to construct and interpret a 95% confidence interval for the mean lead level of crows in the region. So this is our mu. So the logic is the same. A confidence interval is what we're going to use to estimate the value of a parameter based on sample statistics. So before, 1 proportion z intervals, we were estimating p based on p hat. Now with this t interval, we're going to estimate mu based on x bar. The process for doing that is the same. It's 3 steps, right? Conditions, we get to the math, we write an interpretation of an interval, right? And that's it, right? So those big ideas, those overarching ideas are all the same as what we've done before. Now, before we get into that specific process, you might be thinking about, like, when you read this question, right? If you get this on the exam, part of the challenge is, now how do I know if I use a 1 proportion z interval, a 2 proportion z interval, a t interval, whatever, a paired t interval, and some of those things are coming up later. So in general, it's not too crazy if you're working with, for the sake of the AP exam, right? So this is important. The next video is about the t distribution, and so we'll look at the difference between the z test and the t-test, or the z interval and the t interval on your calculator. For now, for the sake of the AP exam, you're working with percentages. You're talking about some kind of 1 proportion z test or interval, or if you have 2 proportion z test or interval. The 1 or the 2 is based on how many samples you have. In determining between z and t, it's, for the sake of the exam, z is going to be a proportion question, t is going to be a means question. So in our context, right, we're working with means. We have 1 sample of 23 crows, and that's how we know we're in this t-test or t-interval. And of course here, hopefully it's pretty clear that we're not doing a test, right? We're creating some kind of confidence interval. Next week, we'll start to look at what happens if I have 2 samples, and then we'll jump into our 2 sample t-test interval context. So this is what you want to think about when you're trying to distinguish which type of test or interval you're going to use. And that's something that we'll practice kind of at the end before the exam, just looking at different problems and reading them and trying to figure out which inferential procedure would I use. So here, right, back to the question. Number 2 here. So the mean level of the 23 crows, right, and that's red. Once I see that, this tells me I'm doing some kind of T, most likely in real life, but on the AP exam, it's a T interval. We've got one sample, so now I know it's not a 2-sample T interval. It's just my one sample, just my regular rolled T interval. Pretty obvious this one we're creating a confidence interval, I hope. But this could say, right, this could say estimate the mean lead level of crows in the region, and hopefully you remember that estimate, the way we estimate that parameter, as I mentioned, is using a confidence interval. So step 1, conditions. The conditions are mostly the same. So this is all just kind of generic notes. Random 10%, same deal as always. Now this, for my students, this right here, this is a different way to kind of interpret the 10% condition that we didn't really get into. Something to think about. The one difference though is we can't check success failure, right? There's no NP hat and N1 minus P hat bigger than 10 because there's no P hat, right? P hat was a sample percentage, but we're not working with percentages, we're working with means. So we can't use that condition. And if we go way back to, if you guys remember our sampling distributions, remember we looked at the Reese's Pieces and then we had the applet with the histograms, the blue bars dropping down. We did previously look at the conditions for means. And so if you flip back in your notebook, you would find this. So now, and this is just in blue because it's the new one. So now, rather than looking at success failure, we got the large enough sample condition. If they give us a large sample, like we literally just say the sample is large enough, we'll say 20-ish is large enough. So our 23 crows is a large enough sample. That does it. If we have a smaller sample size, we actually have to look at the distribution of the data. In this case, we're given a stem plot so we can see that distribution. In other cases, we would have to create a histogram on our calculator quickly, get a quick sketch, and try to see if the shape of the smaller sample is unimodal and roughly symmetric. So this down here, this is the one difference with our conditions. So I challenge you guys to take a minute, pause the video, and check the conditions. And hopefully you wrote something like this. So my students, hopefully these top 2, I mean everybody, hopefully those top 2 are pretty easy. In black here, notice this is a different way you could address the 10% condition. And then in blue, so I chose this problem intentionally for our first example because you could really check the large enough sample condition either way. You could just say 23 crows is a large enough sample, right? More than 20-ish is good. And 20-ish isn't set in stone, that's the ish. Or we are actually given a distribution of the sample data in the stem plot, which seems, oh, there it is, creeping down at the bottom right there. So we can, if you look right, we can see actually the sample distribution right here. Or I should say the distribution of sample data. And like, that's not drastically skewed or anything. That's like roughly unimodal and symmetric. So actually you could check the large enough sample condition either way for this context, which is why I chose this problem. You wouldn't need both of these blue bullets. One or the other would be fine. In most problems, only one's gonna be an option. Like if you're not given the data, it's gonna be a large enough sample. If you're given the data, it's probably going to be a smaller sample, right? They're not going to give us 50 values to put in our calculator on the AP exam and check the size. So conditions, right? No big deal. One new one in blue. Other stuff, same deal as always. So now we come to the math. In my head, you guys were like all in class and you all told me it was the math. But so next up, right, go to our calculator. So stat tests. So now we're talking about this number 8 here. So we have never used number 7, and I will tell you we are never going to use number 7 in this class, but that will be touched upon in the next video when we talk about the T distribution. So this week we're going to focus on numbers 8 and 2. Right now we're working with 8. When you choose that, notice there's a difference here. There's 2 different options for how we can input the information. So we can input the actual data. So I could, right, go to either, right, hit stat edit, and I could put L1, L2, it doesn't matter which one I use, but I could input the actual 23 values that were given in the stem plot into one of my lists. Just tell my calculator which list, like maybe it's L1, maybe it's L5, like whatever, just tell the calculator. This frequency, if you do that, is always gonna be a 1, right, and I can go to calculate. Personally, I wouldn't do that right now because I don't feel like typing 23 numbers in the calculator, so my other option is I can go over to stats, and then I can just enter this, the summary statistics for the sample data. And so in this case, they gave us the sample mean, they gave us the sample standard deviation and sample size, so I can just pop in those 3 values in my confidence level. So in some cases, we will be given the full data set, and then you're going to pop everything in one of your lists. In some cases, we're just given the sample stats. This is a unique case again when we're given both, so you could do either, right? But do what's most efficient. So me, right, I did that. And then of course we go to calculate. There's our interval. Copy the calculator screen, right? If this is a free response in class, we want to copy the screen 1 because it gives us the name of the test or interval, which we always need. There's the actual interval. And then I like to write these down. It kind of forces me to double check, right? If one of those doesn't match what was given, I know I made a typo, and that'll, hopefully make me aware that I should go back and fix it. Down here at the bottom, something we also always need to include is the degrees of freedom. So degrees of freedom did not apply to a normal distribution. So degrees of freedom are something that are specific to the t distribution. I should take that back. There's also degrees of freedom for chi-squared, but for us, they're new to with the t distribution. And this is something else that'll get touched on in the video that's about t. For now, just trust that degrees of freedom are n-1, and we'll talk more about that in the next video. For the sake of going through a free response, I will jump back. I do want to look at the formula for how this was created, where these numbers come from. But for the sake of kind of getting through a problem in the most efficient way possible, personally, I would copy this calculator screen down and I would go right to the interpretation. So here, take a minute. There's the interval, right, that we just calculated. That's what we just did on our screen on our calculator. This is just the context. And so all the things we've done hold true, right? We're 95% confident. That kind of structure of our sentence is the same. We can copy the wording out of the question. The only difference is now, instead of estimating like true percent of whatever, now we're estimating the true mean whatever, right? So we can always copy that wording out of the context. No big deal. So take a minute, pause, and try to write yourself an interpretation of this confidence interval. And hopefully you wrote something like that. And as you look at this, the number one thing I want you to take away is this is like the same thing we've been doing. So there's not a lot of new ideas here, right? There's new formulas and new tweaks, new wording, but the big ideas are all the same. So we're 95% confident. We were trying to estimate the true mean lead level of all crows in the region. So we're 95% sure that that true mean lead level of all crows in the region is between 4.4157 and 5.3843 parts per million based on this data. One thing I will point out, the last confidence intervals were all about percentages. So it was always the true percent or true proportion, which kind of was the unit. Now that we're working with quantitative data though, there are going to be units that we have to consider. So make sure you always pay attention to that and make sure you always include your units. With one prop Z, two prop Z, right? Everything was percents or difference in percents. With means, those units are going to vary with each context. That's it. You should hopefully feel pretty confident that you could do a full free response. Let's take a minute though, before we get to those. Let's jump back. So I'm going to stop this. Oh my God. Hopefully that pause didn't do anything crazy. That was an accident. Let's hop over to the whiteboard and look at where this interval came from. So, confidence interval, 4.4157, 5.3843, right? How do you get those two numbers, or how did the calculator get those numbers? The generic structure of any confidence interval is always the same. Sample statistic, plus or minus, critical value, times the standard error of that statistic. And so everything I just wrote in blue is given to you on your formula sheet. Now this year we're in a weird situation where you're not going to be in an exam given a packet. So right, like that formula sheet could be notes for you. You might print off the formula sheet. Maybe you still have it from school, right? But that's not something that's going to be handed to you for the exam this year, which is a little weird. So like in the past, right, with a one prop Z interval, our sample statistic was our sample percentage p hat plus or minus. This was a Z star because we were working with a normal distribution. And then this was that formula square root p hat 1 minus p hat all over n. And remember that this formula is also given on the formula sheet. So you don't really have to memorize anything if you know what this all means. For us now, we're working with our t interval, which is now for means. So now, no big deal. Instead of our statistic being a sample percentage, our statistic is our sample mean, x bar, plus or minus. The biggest new thing here is we're no longer working with the normal distribution. Now we're working with something new called the T distribution, right? Which next video. So this is something called T star, which varies based on degrees of freedom. If you guys remember when we were in class, when I gave you the T table to look up all the Z stars, they were just the very bottom row. And you guys were like, what are the rest of those numbers? Those are all the T stars. So actually, some of you could probably do it. You would look up the degrees of freedom on the left side and the confidence level on the bottom and just see where those meet. And that's how you would get this T star. That's coming up in the next video. And then now, instead of this formula, right, there's no P hat, so we can't use that. Now we're going to use this SX over the square root of N. And just like this formula is also given on the formula sheet. So the blue stuff is all provided on the exam. So lastly, kind of wrap it up. If I then replace these with some numbers, our sample mean was 4.9 plus or minus. T star, there would be a number here. I'm going to hold off on that, mostly because I don't have the table in front of me. And then we've got 1.12 over the square root of 23. And so when I do 4.9, I wish I had another color. When I do 4.9 plus all this stuff, that's how I get this higher value in the interval. And when I do 4.9 minus all this stuff, that's how I get this. And again, we'll touch on how to look up this T star in the next video tomorrow. But right, no big deal. It's just a number you look up in the table. It's not 1.96. It's going to be bigger. We'll talk about why. That's it. That's the formula for a T interval. Just got to figure out how to replace this with a number so we can like actually do the math. Moving ahead a little bit, like from here, once we create the interval, the types of questions that we see are all pretty much going to be the same. For example, we have some questions like this. So I'm not going to really take a bunch of time to go through these. Pause the video here. I would jot down these three questions. One, does our interval suggest the mean level of crows is less than 5.5? So we want to use an interval to kind of test some claim. We'll actually address a similar question to A with a t-test later in the week. You might even think about how you could just do that right now yourself. B, if we want to alter our evidence, this kind of gives the answer to A so that the mean lead level, so that we don't have evidence that the mean is less than 5.5, how could we change our interval? All the ideas about how the interval widens or narrows, how the margin of error increases or decreases, right? All those ideas are the same. Increased sample size, margin of error goes down, right? Because N's still in the denominator. And then lastly, interpret the meaning of the confidence level, which again is the same thing that it meant before, except now instead of estimating some true percentage, we're estimating some true mean. So give those three a shot. Pause it. Here we go. Here's some answers. Yeah, of course this suggests that the mean lead level of crows in the region is less than 5.5 because the whole interval is less than 5.5. No big deal there, right? And that's all you see. If we didn't want evidence that the mean was less than 5.5, we would need a wider interval so it contained 5.5. How could we do that? Assuming we're going to keep the same sample, the only option would be to increase our confidence level. And this is just showing you that if we change to a 95% confidence interval, I'm sorry, if we change to a 99% confidence interval, our interval does in fact go above 5.5. So now we can't say our whole interval is below 5.5. And so again, just as you're looking at this, right, same idea. It's like, oh, I got this. I understand this, hopefully. And if you didn't, this is going to help us kind of connect all the dots and tie up the loose ends from earlier. And then lastly, so remember, the confidence level is this idea that if we keep taking samples of the same size, making confidence intervals, the confidence level is the percent of the resulting intervals that would contain our true parameter. So I've written that in two different ways. The bottom one's bold because personally, like that's what I'm writing. About a little more concise. About 95% of intervals based on random samples of 23 crows are going to contain the true mean lead level of all crows. So this right here, this is our parameter of interest. This is what we were trying to estimate the mean lead level of all crows in the region. And you can take a peek up here, right? This is just a different way. It feels a little more cumbersome to me, but whatever. It's just a different way to say the same idea. So, oh, hopefully you did that review question number 1 earlier, and then you didn't overthink it. That's it. That's the whole answer. All right. Last thing, we're done. Different context here. So I mentioned that if you're given earlier for the conditions, so this is just solely touching on the conditions. In this context, we only have a sample size of 17. So down here, there are 17 ages of recently paid life insurance policies. So in this case, we can't just say the sample is large enough. We have to actually check the shape of this sample data. And this time we're not given a stem plot, so we need to do that ourselves. You could make your own stem plot, you could make a dot plot, or you could use your calculator to make a histogram. You do what's most efficient for you. With this data, the values are all right, like pretty close together. There's no this would be pretty easy to make a stem plot or a dot plot for it. So if that's quicker for you, do that. For the sake of a little bit of review, this is just telling us we can check the shape. We want the shape to be unimodal and roughly symmetric, and you have to actually show it. So you can't like you got to actually draw the dot plot or stem plot, or if we're going to create a histogram with our calculator, you got to sketch it. That like don't even put any numbers. When I say sketch it, don't even put any numbers on these axes. Just quickly sketch whatever shape you see from your calculator. Hopefully it looks way better than that. By the way, if you got the t-interval stuff down, this is now all review. So if we were going to make a histogram on our calculator over here, right, we're going to pop all the numbers in some list. I like whatever, doesn't matter which one you use. Second y equals to go to our stat plots. Pick one of them. It doesn't matter which one. I picked plot 1. Turn it on. Pick a histogram. Tell the calculator where you typed the data. What color do you want your histogram if you have that option? Who cares? For this one, I did not use zoom stat. Zoom number 9, I chose to set a window because the numbers were all like between 70 and 85-ish. So I just went from 70 to 86 on my x-axis here, counting by 2s. Remember the y-min for our histogram, or the y-axis for a histogram, just our frequency. So I just guessed 0 to 10. From there, just press graph. Don't hit zoom 9, it'll undo all that. And so we can in fact see, right, this is unimodal and symmetric. It's almost like I intentionally made it that way. So last thing, if you were gonna have to sketch this, you're literally on your paper just doing like, I mean, just this with no numbers. Right? Like that's acceptable for a sketch. Everyone knows you're looking at your graphing calculator if we have to do that. That's a terrible sketch, but that's the idea. And so that's how we can check that large enough sample condition. So hopefully you, hopefully this felt comfortable. Hop on Google Classroom now. You got a free response. Do it, score it, submit it. It's due tomorrow. No more saving everything till last minute. I'm going to be a little more strict about the daily stuff so we can kind of get into our routine for Q4 and get into the groove here. All right, everybody. I'll see you tomorrow for the next video. Have a good day.